Okay, so some stats questions. This is the first one we're going to take, and it's a stem and leaf. So it's from the 2014 paper. All of the students in a class took IQ test 1 on the same day. A week later, they all took IQ test 2. Their scores on the two IQ tests are shown in the tables below. Draw a back-to-back stem and leaf plot to display the student's score. Okay, so a back-to-back stem and leaf plot, it's one of the tools. So why do we even draw any graphs like this or histograms or pie charts? That's because in many cases, it's much easier to look at data if it's in a picture format, okay, or in some sort of a display that we can visually see, okay? It's a bit like words and pictures. Sometimes pictures tells us a lot more than the words does, okay? So in many cases, data is plotted into some sort of a graph to allow us to compare it or see it or do whatever. One of the important graphs, I suppose, on your course is stem and leaf plots. These are really good because they show the actual values that were measured, okay? This is what we call the stem, okay? And then the numbers out here would be the leaves. So how do you read it? Well, this is all the numbers in the 70s. So you kind of do have to look up here to see what context. This would be all the numbers in the 80s, the 90s, the 100s, and so on and so forth. So you can compare the two with the same stem. So all of the 70s for IQ test 1 would come back this way, and for IQ test 2 would go this way. Okay, so I'm going to do IQ test 1 first. Okay, so have I any values in the 70s? So there's a few rules, one number per box, and you must put them in numerical order. Okay, so sometimes you might have to do out a rough stem and leaf beforehand, and other times you'll be able to put them in numerical order at the same time, okay? And as I do one or two of them, that will become more obvious. So I do see a number in the 70s. I see just one, so that's that 79 that's there. It's a bit thick, it's hard to read. Do you know what? I'm just going to put a circle around it so I'm still able to read it. So 79, okay? So there's the 79. Okay, I don't have any other numbers in the 70s. Let's look for 80s. So I can see 86 there and 89. They're the two 80s. Yep, okay. So 86, 89. Okay. So 86, 89. So the stem only ever appears once, okay? Okay, let's go to the 90s. So I have a 96, a 96, a 94, and a 97. Okay, so 94 is the lowest. So the 4 goes in first, 96, and you put it in twice, 97. Okay, the 100s are next. (104), 105, 103, 104. Not this one because that would fit into the 11s here, the 110s group. That's a 110s group, 110 group, that one. Okay, so which one is the lowest there? 103. And then I have a 4, a 4, a 5, and an 8. Okay, and then the 3 that are left fits into the 11s. So I have 111, 115, 119. Okay, so the last thing I do is I count 1, 2, 3, 4, 5, 10, 15, and I make sure that I have 15 pieces of data in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, because it's really easy to forget one. Okay, so that's IQ test 1. And now I can see straight away that most people got in the 90s and the 100s. Okay, so now let's look at IQ test 2, and it's the same process. I'm looking for numbers in the 70s. I don't see any. 80s are next, so there's 83. That's my only one. 90s, there's a 99, 97, 97, 94. Okay, and if you forget one, which is really easy to do, so we'd say we pretended we forgot that 97, okay? You'd only probably find out at the end, and you'd probably have the 9 there. Just rub out that 9, put in your 7 and move your 9 out, okay? So sometimes when I'm doing it, I leave bigger gaps between them so that, like for here, I could put in a number if I have to, if I forget one, okay? But you'll find a way of making it work for you after you do one or two of them. So that's 105, I'm on the 10s next, 108, 106, 102, 108. Yeah, so 102 is the smallest, 105, 106, 108, 108. Okay. And then let's do the 11s, 1, 2, 3, and 4. Okay, which is the smallest there, 111, 114. No, look at that, I forgot a 111. 111, 111, 114, 117. Okay, and the last one left is 120. Okay, what's really important then is the key. So this is basically explains how it works. So you pick any value at all, it doesn't matter. I'm going to pick 102 there only because it's right in the middle. So you put in the 10 that's part of your stem, you put in the line and you put in the 2. Okay, so like this. So that's the 10, the line and the 2. And you explain what that is. So it's equal to 102. Okay, so that anybody looking at your stem and leaf knows exactly what's happening. Okay, and there could be a lot of marks for that. There easily could be a lot of marks for that. No bother at all. And then they start asking questions on the data, basically. So there's 5 very important things you have to know in stats. You have to know what is the mean. You have to know what is the mode. You have to know what is the median. Okay, so I'm going to practice those with you over the next few classes. You then need to know what is the range and what is the interquartile range. Okay, so 5 different ones. So that's what we're going to practice through these questions. So the first one says, find the range of scores. Okay, so the first formula I want to draw your attention to is range. Okay, and it's equal to max minus min. Okay, so that's the first formula you need to know. So what does that mean? Well, this means the biggest value, take away the smallest value. So that's how we get the range, okay? So for example, if I asked you what was the range of ages in your class, you would take the age, probably in years and months, of the oldest person, and you'd subtract off it the years and months of the youngest person in the class. So that would be the range of ages. So we're going to look at the range of scores, okay? Now that we've ordered the data here, it's very easy to see that the biggest value is 119, okay? And the smallest value is 79. Now you can trawl through the data to find the biggest and smallest as well, but this is the easier way of doing it. So 119 minus 79, wasn't it? Yeah. So take them away on your calculator and you'll get 40. So that was IQ test 1. And then you do the same for IQ test 2. Again, the biggest value is 120 and the smallest is 83. So 120 minus 83 is 37. Okay, so you can see the maths per se is not hard. Okay, that's just subtraction. No bother to you. You'd have done that in national school. What's been examined here is that you know all of these measures of statistics. So what is the range? Okay, so the next question asks for what is the median. Okay, so the next formula I want you to know is median n is equal to the value in the middle when the numbers are in order. I call it numerical order, if that makes sense. So in other words, they're going from lowest to highest, okay? So the value in the middle when the numbers are in order, okay? So what did we say was here? 15 numbers, okay? So you can start counting backwards. What I find very handy for median is to write the numbers down in a row. So, and it does take a minute, but I think it's really easy for working it out. So the first number there is 79. My next number is 86, followed by 89. Followed by 94, 96, 96, 97. I'm reading them all from here. 94, 96, 96, 97, 103, 104, 104, 105, and 108. Why am I doing them from the stem and leaf and not from up here? Well, it's because these are in numerical order. So remember what I said median was. It's the value in the middle when the numbers are in numerical order. Okay, so me reading them off the stem and leaf that I've already done is having them in numerical order. So I was at 108, so the next one is 111, 115, 111, 115, 119. That's it. Okay, so 15 values, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so find the number in the middle. So 1, 2, 3, 4, 5, 6, 7. I'm thinking 7 and 7 is 14. 1, 2, 3, 4, 5, 6, 7. Okay, so that's where I'm at there. 1, 2, 3, 4, 5, 6, 7. Okay, 1, 2, 3, 4, 5, 6, 7. So what I did was I counted up 7 from the bottom and I got to 104. I counted down 7 from the top. So can you see now that the value in the middle is 103. So that is my median for middle, okay? It's also called the second quarter, okay? Because second quarter is a half, okay? And that is the number that is halfway down. So my median for Q1 is 103. Okay, I hope that makes sense. I'm going to do the same thing now for IQ test 2. It is possible to do these on the stem and leaf, guys, and some people are really good at them. You can go, there's my first value, my second, my third, my fourth, my fifth, my sixth, my seventh, and that's you at 97, okay? And then you have to be careful though when you're coming backwards because you have to start on the outside. From the top down, you start on the inside and go out. But when you're counting backwards, you start on the outside. So 1, 2, 3, 4, 5, 6, 7. Okay, and there's your 103. So you can do them off the stem and leaf by all means. I just find this a safer way of writing them out. So 83, 94, 97, 97, 99, 102, 105, 106, 108, 108, 111, 111, 114, 117, and 120. So you can see it doesn't take long once you get used to it, reading off it. So again, the same thing. I'm going to count 1, 2, 3, 4, 5, 6, 7. So 105 is my value in the middle there. 1, 2, 3, 4, 5, 6, 7. That's 7 up. So in this one, I can see 106 is the median for this one. Okay, so 106 is my answer there. Okay, I hope that makes sense. Find the mean score for each IQ test. Okay, so mean is a fancy word for average. Okay, and how do we get the average of something? Add all up and divide by the number of numbers. So however many you've added up, that's what you divide by. So that's how we get the average. Okay, and we're going to do it here for IQ test 1. Okay, so again, you can do it off the stem and leaf, or you can do it from the table. Okay, so I have the numbers in front of me here now because I knew I'd have to do this, otherwise I'd be scrolling back and forth. Okay, but I am taking these from our stem and leaf. So what I'm doing is I'm adding up 79, and if I was doing it in an exam, I would probably write down average. I would then add up the 15 numbers and get whatever that is, divided by 15 and equals to the answer. Okay, I don't think in an exam I would necessarily write out what I'm about to write out, okay, because you could make more mistake trying to write this out than you would putting it into the calculator. Okay, so 89 plus 94 plus 96 plus 96 plus 97 plus 103 plus 104 plus 104 again plus 105 plus 108 plus 111 plus 115 plus 119, all divided by 15 numbers. Okay, so you can see what I mean by I wouldn't necessarily write it out like that because I don't think it's overly helpful. So when you add them up, put them into your calculator, you should get 1506 over the 15 divided in, and you get 100.4. So that's the average, okay? And if you think what the word average means, if you were to look at the people who lives in your house and you were to get the average age, so your age is either 15 or 16 or something like that, and your parents' age is I don't know, maybe in the 40s. If you add all the 3 ages together for your 2 parents and you and divide by 3, you'll see you'll probably end up with your answer somewhere in the 30s. In other words, it'll be in the middle of your parents' age and yours. It's the average, it's the one in the middle. Okay, so when I see an average here of 100 and I'm adding numbers between 79 and 119, and they're kind of going up by the same amount, that feels right. That feels like it could be the average or the middle number of all of them. Okay, and then for IQ test 2, it's the exact same idea. Again, we add them all up. So 83 plus 94 plus 97 plus 97 plus 99 plus 102 plus 105 plus 106 plus 108 plus 108 plus 111 plus 111 plus 114 plus 117 plus 120, and again all divided by 15. Okay, so when you do that and you add them up, you'll get 1572, and again it's over 15 and you get 104.8. Okay, so I hope that makes sense. You may have to do that twice to avoid making a mistake, because you can see how easy it is to put one of those numbers in the calculator incorrectly. Okay, so the next question then is really the higher level part, okay? When they ask you to explain what you've just done. So it says, compare the scores on the 2 IQ tests. Refer to at least one measure of central tendency and at least one measure of variability or spread in your answer. Okay, measures of center or measures of central tendency is your median, your mean. So we found both of them, and there's a third one called mode.
Yeah.
Okay, so measures of variability are range, or there's another one called interquartile range, and we'll be coming to that now in a minute. Okay, they are your measures of spread. So what do they mean? Well, median, mode, and mean looks at what is the center value of your data. Okay, so for anybody who has plotted a histogram, for example, a histogram, I'm going to, if you can imagine me now, I've turned my page sideways. I obviously can't turn it for you, but I've turned it on its side, and these are the bars of my histogram. Okay, so I've turned my page 90 degrees, and can you see it's like a histogram standing up? Okay, so when you look at measures of central tendency or measures of center, you're going, well, what are the bulk, what are the main values in the center of my data? Okay, so that's why the median value of 103 in this one, you can see, shows the center of your data. The mean, what do we get for the mean? 100, again, falls somewhere in the center block of your data. Okay, so it's just all describing your data. And then the spread looks at the distance between the biggest and the smallest value. Okay, so that's also a really good thing to know. So in other words, if a teacher gave you a test and some people got 100% and others got 20%, then she would say, or he would say, there's a huge spread among the values people got in that test. Okay, so compare the scores of the two tests. Okay, so you're looking at them and you're wondering, are they similar? Do you think they're similar? Do you think they're different? And this is the bit that's hard. Now, why did I do that? Okay. Are they similar? Are they a little bit different? So on and so forth. Okay. They're a little bit different, I would say. In IQ test 1, there was somebody's in the 70s, whereas in IQ test 2, there's someone in the 120s. Okay. But the bulk of the students are scoring roughly the same. Okay. Then let's have a look at some of the measures we took. The range for IQ 1 is a bit bigger than the range for IQ 2. When we look at the medians, the value in the middle, this one's a bit higher. So that means people are scoring higher on IQ test 2. And if we look at the mean again, that's also a bit higher. Look at that. So people are scoring higher in IQ test 2 than IQ test 1. Okay, so that's the first thing I'm going to put down. What were they called? People or students? Students. Students scored higher in IQ test 2 compared to IQ test 1. This can be seen from the mean and 104.8 versus 100.4 and the median. I can't remember what they were, 106 versus 103. Okay, let's have a look at the range. The range on IQ test 2 is a little better, a little tighter maybe, than IQ test 1. But they are quite close. Okay, or something to that effect. You can kind of say anything like that. You can say the scores in IQ test 1 are a little bit more spread out, okay, because it's got a value of 30 or its range is bigger. Or you would also have been perfectly okay saying the range was very similar, okay, because when you're scoring up in 119s, a difference of 3 doesn't matter that much. Okay, so that was part 5. Part 6, Marshall says that every student in the class must have done better in IQ test 2 than in IQ test 1. Is Marshall correct? Okay, can we say that every student who took IQ test 2, they all did better than IQ test 1? Well, I would say no, we can't say that at all, because nowhere does it tell us which student got which result. So couldn't it be the case that this student who got 103, for example, might have got 94 in the next test? Okay, so therefore he'd have done worse in IQ test 2. Okay, or the student who got 119, the best in IQ test 1, maybe got 111 in IQ test 2. So there's no way of knowing that every student did better. Okay, so is Marshall correct? No, I don't think Marshall is correct. We do not know. We do not know which scores belong to which student. Okay, and sometimes I think it's easier to give an example. So something like a student could have got 119 in IQ test 1, but got 111 in IQ test 2. Okay, something like that. Okay, but what we can say is that on average, the students did better in IQ test 2.